Variable valve timing or camshaft phasing has given us many benefits, including more power and better fuel economy. In this video, we'll look at diagnosing actuator faults. There are two different types of controls for camshaft actuator valves. One controls the valve with a pulse width modulated or PWM ground and has a 12-volt supply, as in this schematic. And the other has a low reference and is controlled by a pulse width modulated 12 volts, as you can see here. This video will be concerned with the actuators controlled by a PWM ground. Here is a list of DTCs that can be set for faults associated with the camshaft position solenoid actuator. If the system you're working on uses PWM voltage control, check out the diagnostic video Camshaft Actuator Positive Control. It can be seen that these DTCs cover shorts to ground, high resistance, open circuits and shorts to voltage. The camshaft position actuator system enables the engine control module, or ECM, to change the timing of the camshafts while the engine is running. The position of the valve will be determined by the PWM on time. The camshaft position actuator solenoid valve varies the oil flow that applies the pressure to advance or retard the camshafts. Note, if a crankshaft or camshaft position sensor DTC is set, the camshaft position actuator output control will not function. So deal with any of these DTCs first. Make sure when checking actuator DTCs that the conditions for running the codes are met. For this vehicle, the ignition voltage must be greater than 11 volts, the ignition switch is in the crank or run position, and the ECM has commanded the camshaft position actuator solenoid valve on. If you have a scan tool that displays the camshaft information, then check this first. This scan tool has desired and actual readings. The desired angle is the ECM's calculated position for each camshaft, and the actual angle is what the camshaft sensor has detected. The engine speed will need to be increased. The best way to view the data is in graph form. Using an oscilloscope is another way of confirming that the information is reaching the actuator. This, however, will not tell you if the data is correct. A fault could be in the module, the wiring, or the actuator. If it's determined that a fault exists, it will be necessary to carry out the following procedures. As always, check battery voltage before performing any tests. Disconnect the harness connector at the camshaft position actuator solenoid valve. With the ignition on, connect a multimeter between the supply side of the connector and chassis ground. You should see battery voltage. A low voltage here will indicate a resistance in the circuit. This could be in the wiring, the fuse, or the fuse box. Test the voltage at the fuse. If there is now 12 volts, then the resistance will be in the harness. If the voltage is still low, then check the fuse and its terminals for corrosion and correct tension. If all appears fine, the fault will be in the fuse box. No voltage at the connector indicates an open circuit or a short to ground. Check the fuse. If this is okay, you'll need to locate the open circuit. If the fuse is blown, set the multimeter to ohms and check the resistance from the connector to ground. A low resistance here indicates a short to ground. If this side of the circuit has no faults, then move onto the control side of the circuit. Connect a multimeter to the actuator connector control terminal and battery positive. To get a reading, you will need to trigger the actuator with the scan tool, if yours has this feature, or by starting the engine and increasing the RPM by quickly opening the throttle. You should see a voltage change when you increase the RPM. If there is no voltage change, turn off the engine, backprobe the module and retest. Voltage here would indicate an open circuit to the actuator. If there is still no voltage, then test the connector for terminal tension and corrosion. The module will be at fault if no problem is found with the terminal. If both circuit tests reveal no faults, you can check the actuator. Using a multimeter set on ohms, check the resistance of the actuator and compare it to specifications. An incorrect reading or an open circuit indicates a faulty actuator. If within specifications, you can perform a dynamic test on the actuator. This is done by connecting a fuse jumper from battery positive to the supply terminal on the actuator, and then connecting a ground to the control terminal. The actuator should click. If there is no click, then replace the actuator. A click will indicate there is a problem with the oil supply to the actuator or the camshaft phaser. Camshaft actuators usually won't prevent an engine from running, but will affect performance and fuel economy. Follow the procedure, diagnose, don't guess. And remember, training is knowledge, the knowledge to keep you ahead of the game. Bye for now.